Hi, I'm Bryant for your tutoring high school physics. Today's topic, multiple resistors. So if you have more than one resistor, there are two ways in which you can hook them up in a circuit. So you can hook them up right next to each other so the electrons have to pass through all of them. This is known as putting them together in series. Or you can hook them up so the electrons can go through either one or the other. This is known as putting them up in parallel. So let's look at the differences between them. If you're hooking up your resistors in series, the voltage across each resistor is going to be different, but the current through all of them is going to be constant. To find the total resistance of resistors in series, just add up the resistances. So we can actually simplify this original diagram and call these both one big resistor. So we have our battery, we have two resistors, one 1.5 ohms, the other 0.5 ohms, so we can add those together using this equation to find that the total resistance is going to be 2 ohms. So you can basically consider them one big resistor with resistance of 2 ohms. Okay, so now we can start using Ohm's law to try and find out the current through this. So V equals IR, we have a voltage of 5 volts. From this battery, we have a current that is unknown and a resistance of 2 ohms. We divide both sides by 2 ohms and we get a total current of 2.5 amps. Okay, so we have our total current, which is going to be constant throughout the entire circuit, but the voltage is going to differ across each resistor. So we can solve the voltage individually for each resistor now. So we have our voltage that is unknown, but we do have a known current of 2.5 amps, and across the first resistor we have 1.5 ohms. And so now we can multiply that together and we're going to end up with a voltage of 3.75 volts. So that's going to be across our first resistor. Across our second resistor, again, we can do V equals IR. Unknown voltage, because that's different across each one. A known current, because that's the same, 2.5 amps, times our new resistance of 0.5 ohms. And we run that through, we get 1.25 volts. And so that's the voltage across the second resistor. And notice if you add these two voltages together, you get 5 volts, which is the total voltage of the entire current. Okay, so what about resistors in parallel? Here, the voltage is constant across each resistor, but the current is going to be different across each one. To find the total resistance, take 1 over that with total resistance, and it's equivalent to 1 over the resistance of one resistor plus 1 over the resistance of the other resistor, so on and so forth for all of your resistors in parallel. So let's actually try and simplify this one. So we have 1 over our total resistance is equivalent to 1 over 5 ohms plus 1 over 1.25 ohms. So 1.25 ohms is in fact going to be 5/4, so if we flip that over, that's 4/5. So 1/5 plus 4/5 is going to equal 1. So then our total resistance, if we flip that over, is still going to just equal 1 ohm. So if we simplify this, we have just one resistor with 1 ohm of resistance. So now we can find the total current throughout the entire thing. So V equals IR. A voltage of 5 volts equivalent to our unknown total current times resistance of 1 ohm. Divide by 1 ohm, and we have a total current of the entire thing of 5 amps. But recall that the current is going to be different through each of these. So you can solve for each individual resistor using, again, V equals IR. So V equals IR. Remember that our voltage is constant, so we have a constant voltage of 5 volts, an unknown current through our first resistor of 5 ohms. We divide both sides by 5, and we get a current through the first resistor of 1 amp. What about the second resistor? Well, once again we set up V equals IR, we have a voltage of 5 volts, we have a current that is unknown, and a resistance of 1.25 ohms. Okay, so now all we need to do is divide through. And if we do that, we get an I of 4 amps. And notice that if we add together our two currents, we'll get the total current running through the entire system. Okay, so those are the basics. You might, though, get a problem like this, which is a little more complex. So what we're going to do is we're going to simplify all the resistors in this particular circuit. So we start out with a battery, and we come along, we find out we have a parallel and then a series inside the parallel. So let's just first do the series. We have 2 ohms up here, that's not changed, and then we're going to add these two resistors together to make another 2 ohm resistor on the bottom. And you go along, this is just 2 ohms, not hurting anybody, we'll leave that alone. Okay, so let's start simplifying this stuff. So over here we have 2 resistors in parallel, so let's do that. So our total resistance is equivalent to 1 over the resistance of one, which is 12 ohms, plus 1 over the resistance of the other, which is another 12 ohms. That's going to equal 1/6 of ohms. So we're going to flip that over to find the total resistance, and we're left with 6 ohms. Okay, so that's one of our resistors down. I'm going to label that 6 ohms. Here in the middle we have a 6 ohm resistor that's not really hurting anybody, we leave that alone. Here we have 2 resistors in series, 4 and 2, so we add those together to get another 6 ohm resistor. Okay, so we're going to connect that right back up. And there we have a slightly more simplified circuit, but let's keep going. Okay, so now we have two resistors in parallel, so our total, 1 over our total, is equivalent to 1 over 2 ohms plus 1 over 2 ohms. That's going to equal 1 over 1, which is just 1. Flip that over, we still have 1, so we have 1 ohm. This is our 1 ohm resistor. We have another 2 ohm resistor here. Move right along. Okay, so 3 resistors in parallel. So 1 over our total, equivalent to 1 over 6 ohms plus 1 over 6 ohms plus 1 over 6 ohms. So that's going to equal 3 over 6, which is just 1/2. So it's going to be 1/2. Flip it over so we get our total, and that's going to equal 2 ohms. So I have a 2 ohm resistor here. So finally we just have 3 resistors that are all going to be in series. Let's pull this down here. All we have to do is add them up. 1 plus 2 plus 2 is going to equal 5. So 5 ohms. We had a voltage of 5 volts over here. So now to find the total current running through our system, we just do V equals IR. A voltage of 5 volts equals our unknown current times resistance, total resistance of 5 ohms, divided by 5, and we have a current of 1 amp. Alright, to recap. There are two ways you can hook up multiple resistors in a circuit. You can hook them up in series so the current has to pass through all of them. In this case, the voltage across each resistor is different, however the current is going to be constant. To find the total resistance of all your resistors in series, just add up their resistances. Or you could hook them up in parallel so that current can flow through either of the resistors, either of all of the resistors. In this case, the voltage across each resistor is constant, but the current across each of them is different. To find the total resistance, you take 1 over the total resistance, and set that equal to 1 over the resistance of one resistor plus 1 over the resistance of the other resistor, so on and so forth for all of your resistors in parallel. If you're working with multiple resistors in different configurations, try and simplify the entire circuit diagram until you're left with only one big resistor. Alright, that's all for now. Again, I'm Bryant. See you next time.